Hi all, we're just going to wait another minute or two for people to find coffee and get in and that sort of stuff.
It's better to close the door. Yeah.
Ooh, better.
What do you think, we can start?
Sure.
I don't know if Sarah will connect, probably not. We can just start. Okay. Okay, let's start. Welcome everybody. This is benchmarking methodology working group session. So I'm Giuseppe. My co-chair is Sarah. Is supposed to connect remotely. I don't know. Anyway, Warren will help. Yeah. Of course, we are in an IETF meeting, and this is a reminder of the policies that affect different aspects like the disclosure of patents, our code of conduct. So please have a look, read that information. We also have note really well about the IETF anti-harassment policy and procedure and guidelines for conduct. Also in this case, have a look. Yeah, regarding the IETF meeting tips, make sure to sign into the session through Data Tracker or by scanning the QR code in this room. If you use Meetico, if you want to join the microphone queue, of course, you can use the client to participate. For remote, since we are a lot of people connecting remote, make sure that your audio and video are off and use headset, please. We also need note takers, so please help to take notes. Everyone is welcome to help, so we have a collaborative client. Any volunteer in the room? Okay, thank you, Paolo. Okay, let's go with the agenda. We have the usual update on the working group status with the chair slide. Then we will go through the 3 working group drafts. on multiple roles ratio research, young data model for network tester management, and consideration for benchmarking in container infrastructure. Then we have 4 proposals to discuss. So the recommendation for multiple IP addresses in benchmarking tests, the benchmarking methodology for segment routing, the benchmarking methodology for power in network devices, and then the SRv6 service benchmarking guideline. Any bashing for the agenda? Okay. Regarding the status, of course, we always need reviewers. So, of course, your work is adopted, completed, and published when the participant read other draft review. So please participate and review the documents. We have some ongoing proposals. The benchmarking in container infrastructure recently adopted. Also, the benchmarking methodology for segment routing that is a merge of 2 previous drafts, considering the comments received in Prague. So we also need some feedback here. Also, new proposals are coming. So the benchmarking for energy efficiency of devices and the SRv6 service benchmarking guidelines. Regarding the activity, after Prague, and the draft on stateful NATE XY has been submitted to SG. And we also have a new working group adopted. The last RFC published is in 2023. We will also update the milestone on stateful NATE XY to publish, and the charter is stable. Yeah, again, regarding the milestone, possible new milestone will be discussed after this meeting and review with Warren. I think that's all for my slides. Okay, we can go through the first presentation. Maciek or Bratko?
Yes, we are here. Can you hear me?
Yeah, can you hear me? Can you hear you?
Yeah.
Please.
Yeah. Thank you, Giuseppe. It's Maciek here, and we also have Ratko on the line. So good afternoon, good morning, everyone. All right, so let me give you everybody an update on our MLR search draft. We have published version 6 a few weeks ago. Next slide, please. Thank you. So the main changes from version 5, we cleaned up the content and the text, and we added one chapter clarifying exactly how we are addressing the problems identified as part of the draft, and we also clarified lots of inconsistencies in the language used. And from Ratko and my perspective, draft is now ready for review. Next slide, please. Okay, so last time in Prague in IETF 118 in November, we have spent quite some time walking through the content of the draft, the problem statements, and the way we're going about it. And we also spent some time on results, but we haven't really had much time on that. So this time around, we decided to quickly highlight what MLR search is, and then spend most of the time discussing the basically applicability and the results from our project in Linux Foundation Networking Fast Data I/O VPP. So let's go through that. Next slide. So MLR search stands for multiple loss ratio search. and it's a new network throughput testing methodology that extends the binary search defined in RFC 2544. The main goals are focusing on improving the efficiency in terms of time, supporting multiple loss ratios, and also improving results, repeatability, compatibility, with the main target being really testing the software-based network data planes. Next slide. The 5 main problems that MLR search is addressing are listed on the slide, so I'll quickly walk through them. Long search duration, doing the standard bisection takes time, and in the software-based networking world, so I'm having some issues with my audio. Can you still hear me?
Yes, yeah, we can hear you.
Okay, all right. As software networking systems follow the continuous integration and continuous development, time is of essence. So reducing the duration is critical. The device under test in our case are applications that are sharing servers. So and the servers treated as the systems under test are clearly multi-tenanted. So DUTs are subject to interference, and the way that the throughput search, it needs to deal with that, specifically in the presence of noise from noisy neighbors or operating system. And that also has an impact on repeatability and comparability of the results. So MLR search basically models the behavior of the system under test as not a single type of behavior in terms of throughput, but as a spectrum for basically thinks or considers it from the noiseless and noiseful part of the spectrum. In many cases, users with the testers and developers and the users themselves accept a small non-zero loss ratio, and that is something that MLR search takes into account, making it more user-friendly. And due to the environment that the software data planes operate in, as the behavior may change during the testing, the algorithm needs to deal with the inconsistent trial results. Next slide. So the way that MLR search deals with it, it improves or reduces greatly the execution time. We're using the concept of preceding targets. So the preceding targets are different than the final target, and they converge to the final target. And we also use various tricks to arrive quickly to the interesting region, something with pre-initial trials. The DUT in SUT is characterized by, as I mentioned earlier, a spectrum of performance, noiseless performance on one end of the spectrum and noiseful on the other. And the actual DUT measurement problem, or DUT in SUT measurement problem, is reduced by just estimating the noiseless part of that performance spectrum. With multiple trials and noise tolerance, configurable noise tolerance, we can increase the result stability. Radko will go through some of the results of that, and also with that, we are addressing some of the and achieving the same benefits as already defined in other documents that Al Morton and team have authored, like the binary search with loss verification noted as per slide. They will have a number of different configurable parameters, and which again improve repeatability and compatibility. I think for the rest, they seem to be quite obvious. We do, users can configure multiple search goals with different configurable loss ratios. So we use two main ones: non-drop rate (NDR) and partial drop rate (PDR) to characterize most of our test results in Linux Foundation networking. And I think with that, I'll hand over to Radko. Next slide.
Okay.
Radko?
Bratko, go ahead. We cannot hear you, Bratko.
I see Radko in the room, but I'm not getting any audio.
His audio looks active, but we cannot hear him.
Okay, Radko seems to be having some audio problems. Clearly. So let's see if he can fix it. I have him offline here. If not, I'll continue in a moment. So just give us a moment, please.
Yeah, no problem. Yeah, we can give a few minutes.
Okay, he is fixing it.
Maybe if I can suggest, when you start the Mythico client, you have to authorize to use the microphone, to use the audio tools. Otherwise, probably miss this step. I don't know.
Okay, Radko, if you could let me know if you are able to fix that issue. If not, you can use the messenger or some other way to communicate back. There's also a chat client right here.
Yeah. Otherwise, can you present on his behalf or
Oh, of course I can. But he's here. He woke up really early on a CET time. So, but I'm happy to continue in the sake of time.
Yeah, the next time I will suggest to test the Mythico client before joining the session, because you can check the audio and you can do everything. So
yeah. Okay, looks like Radko is struggling with audio, so I'm gonna then continue. And Radko, please, when you fix it, I'm happy to hand over.
Hello, can you hear me now?
yeah, we can
hear you now.
Oh, okay. So after 3 times logging out and logging in, now it works. That happens. Okay. Hello everyone. This is a slide that contains real data as measured in our lab on physical boxes running virtual duty, and I will talk about the details later. This is mostly for offline viewing. There will be a smaller version of this graph later, so we can go next slide. And this is the same data, just numerical values, averages, and standard deviations for people who do not like to look at dots, but like to look at numbers. Next slide, please. Okay, this is the important slide that tells about what is going on that graph. So the most important thing are the blue dots, because those are durations of the search. So there are 4 groups of measurements, each one at least 10 runs, and you see that the more right you go, the lower the duration is, and also the standard deviation of that durations is lower, which is better. If you run multiple tests, you can better tell how long it will take. The important part is that the 4 groupings are all using the same DUT, the same library. The only difference is the search goals that were configured for that particular run. So first I should tell about the other 2 colors. So there is yellow color, which is finding values related to 0 loss. And there is a gray color, which is related to the values related to loss of 0.5%. And one of the important consequences is that you can see that this type of results is not very sensitive to the differences between the configurations. So this is one of the reasons why non-zero loss ratios are good goals, because it makes the results stable even if some data are different. But the interesting part, the part of the blue one, which is most important, is the orange one, because on the far left we have such a combination of attributes that it makes the result unconditionally compliant with RFC 2544 throughput definition. So that group of orange dots on the far left is what you can get if you follow RFC 2544 exactly, but using our library, so saving some time, but the last few measurements are such that the results are compatible. And as you see, there is quite a high standard deviation compared to other groups. So maybe let's talk about the next one from the left. This is a change. The most important change is that the final trials are not required to be 60 seconds long, but there still needs to be data equivalent to 60 seconds. In this case, it means 60 trials, each having only 1 second. Okay, in this particular case, it is interesting that the performance average actually went down. This means that for this particular DUT, the length of the trial is not very like it is not making results worse if you are running longer trials. Instead, what makes results worse is if you run multiple trials. The conclusion is that this particular DUT is likely to lose packets at the start of the trial because of some memory caching or whatever, and this change of the configuration made the results worse compared to RFC 2544. And the middle right is basically the same, but now not 60 trials are required, just 21. The only reason is to save time. If we are no longer compliant, we can do other changes. So you can see the duration improves nicely, and as expected, the average of these orange dots goes slightly up because there is a smaller number of chances for a trial to get non-zero loss. And the final, on the far right, this configuration uses exceed ratio, which is the configuration attribute that allows some trials to exceed this loss that is configured and still be considered good if there is enough trials that do conform to the ratio. So in this case, the exit ratio is 50%. What is expected is that those orange dots go nicely up because, of course, now you can have multiple lossy trials and still get some good results. Also, what is expected is that the standard deviation of those orange dots is smaller than before. This makes the results more repeatable. What is also interesting that the duration of the search also is slightly smaller average and smaller standard deviation, which is very good. And basically, the far right results are what we are using in our project CSIT for measuring performance and comparing and other things. And I think that's enough for this slide. Next slide, please.
Radko, sorry, can I just make a quick comment on the previous slide?
Yep.
Please. So I'm not sure you covered that, but the blue dots, if you they characterize the overall duration of the tests. So comparing the leftmost with the rightmost, as you can see, worst case in the leftmost is 8 minutes for the full execution of the whole search cycle. And on the most right, we drop it down to about 2 minutes. So that's a 4 times gain in terms of reduction of the overall duration. So that's just one thing I wanted to highlight. Thank you.
I mean, that was expected when we made the change from 60 to 21, but yeah, it is interesting that the worst case on the far right is basically the same length as the best case on the far left.
Yep, thank you.
Okay, so next slide, please.
Yeah.
Okay, if I am correct, the green, confirm, no, the brown and yellow values are those that were on the far right, and I have added a few more values to compare different settings. What is interesting in this comparison is the green dots. Those are forwarding rate at a maximal offered load. That shows you that for this particular DUT, when you allow for 0.5% loss, you get basically the same forwarding rate as if you tolerate any loss. So you cannot basically get better results, but it is interesting that this setting is so close, while zero loss, even with a 50% exit ratio, is still some distance below. Okay, next slide, please. Yeah, and I forgot to mention that those are screenshots from our production user interface showing the real results. And shortly I will upload a fixed presentation because when doing conversion to PDF, we lost those links. So when you see a link to trending graph and you click on it, you do not get the same configuration as shown here in the fixed presentation. You will have the link that basically recreates this view. Okay, so this is trending testing, which means that the software side of DUT can be different. In each dot, I think this is roughly weekly, and you see that for our DUT, the performance is quite stable. The standard deviation corresponds to the previous case, which was testing the exact same DUT build, and there is one big regression and followed by big progression that restored the performance before. And yeah, I think that's all for me. Next slide.
Right. So yeah, from our perspective, the draft is now ready for a review, and we would like to progress this towards the last call. Any questions, comments?
Yeah, any question? Okay, I want to thank you for this nice presentation, to share the slide, to share also the test results. As a chair, but as a participant, I have read the draft, and I have a comment. I have a question for you, a clarification question. So I have noticed in the architecture that you have a controller. So I'm wondering whether you are considering, it's just for my curiosity, so if you are considering some specific protocol or young model for the configuration of the tester, or it's a proprietary solution. So since it was not specified in the draft, so I'm curious about that.
Yeah, from my point of view, the integration between controller and measurer can be formalized, and I think it can be doable. But the integration between manager and controller is not as clear, because there are many possibilities for optional arguments. Basically, different libraries can implement different optional attributes. The best example of that is the goal width. Some implementations may use absolute difference in performance. Some implementation may use relative difference, and it will be hard to create something that is formal but still allowing every possibility. And in future, there may be like even greater differences between the inputs to the controller. So that will be hard, but yeah, definitely the integration between controller and measurer can be formalized. Those can be programs running on different boxes with a specific protocol between them, and yeah, all the Yang stuff.
Yeah, okay. Yeah, okay, it makes sense. Yeah, if you maybe can add these considerations in the section about the controller, yeah, it would be good, I think, for the reader to understand how the approach that is general and is open to different kind of, yeah.
Yeah, I was not sure if it is in scope. We have another draft that is related to basically modeling something that works as a measurer in our case. It is still not finished, so I was just like talking about it in the abstract point of view. Maybe there can be another document specifying.
Yeah, no, I was just saying, put in the document that the specific, let's say, configuration protocol is out of scope because etc. Just this, so the reader is aware that.
Okay, we can add this
Yeah.
sentence.
Yeah, we'll do that. Thank you.
Okay, thank you. Yeah, if there are no other comments, maybe we can go with the next slide. And regarding, yeah, your last call request, we can further discuss on the list, and I will also discuss with Sarah, but basically we will need some review on the list, yeah, for that.
Okay, thanks very much. Thanks everyone. Thank you.
The next presenter is Vladimir. Vladimir, are you online? I don't see Vladimir online, so maybe we can skip this presentation for now and go to the next and then come back to Vladimir. He will be back online. Meanwhile, maybe I will send him a message. Yeah, we have Mingong.
Hello, can you hear me?
Yeah.
Okay, thank you. So today I'm presenting the first versions of the recently adopted draft. That is a consideration for benchmarking network performance in containerized infrastructure. So this is the first version after being adopted, so I will review every content of the draft alongside the new update based on the comment of the previous meeting. Next slide, please. The scope of the draft is to fill in the gaps of the previous NFV benchmarking RFC, that is RFC 8172 and 8204. So we discussed about the gap of this work when applying to containerized NFV infrastructures. The consideration gaps of the previous work are the different network models and topologies configured by container network interface and the resource configuration for containers. Next slide, please. So the first is the networking model. So the difference with the VMware infrastructure is that network in container-based infrastructures is configured by a specific container network interface CNI plugin. And this CNI plugin inserts an interface in the container network namespace and connects to the host network namespace. The network configuration methods are different between CNI plugins. So because of that, different CNI plugins create different kinds of containerized networking model. In this draft, for each of the model, we mentioned about the model architecture difference, the multiple model example, and the model repeatable environment setup guidance. And this is the newly added part based on previous meeting command. Next slide, please. So about the networking models, there are 5 different networking models for containerized infrastructure. The first one is the kernel space non-acceleration. Inside this one, its characteristic is that the packet processing to the switching and routing component as a host kernel namespace. Notable are the kernels, Calico non-eDPF, and OpenP switch. The second architecture is user space acceleration. For this one, the packet process bypass the kernel space network stack so that the packet is accelerated and traverse to the user space vSwitch. Notable are the OS DPDK and the VP user space vSwitch. The third is the eBPF acceleration. For this one, the packet processing bypass kernel via eBPF program path. Notable are the Cilium AF80 plugin and vSwitch with AF80 support. The fourth one is a SmartNIC acceleration. For this one, the packet bypass kernel via the SmartNIC features like virtual function or the upload eBPF in Cilium. Notable examples are the SRIOV and Cilium in upload eBPF. The final is the model combination. So containerized network can combine the SIOV and the user space vSwitch model for the north-south and the east-west traffic. Next slide, please. About the repeatable environment self-recommendation, this is a new part. We add the recommendation for each of the model. So the general recommendation for all of the model is that Kubernetes needs to be used as a container platform. It's the most popular right now. And the Mantis CNI also need to be configured to enable multiple network interface of the containers. And for specific recommendation for each of the model, the kernel space non-acceleration, we just simply need to install the corresponding CNI. For the user space acceleration, then the DBDK libraries and need to be installed. then the link port should be bind to the BPTK point mode drivers. Then the district need to be configured, and the required CNI plugin is the user space CNI. For eBPF acceleration models, and the corresponding CNI needs to be installed here, either Cilium or the AFXTP CNI plugin, based on the chosen kinds of eBPF acceleration network. And in case of using the vSuite with the AFXTP eBPF support subtype, then the required user space CNI plugin need to be installed as well with the vSuite configuration, the same like the user space acceleration model. The recommendation for the SmartNIC acceleration, then BPTK libraries, SIOV category card, and the BIOS virtual function support feature need to be enabled. Then the virtual function need to be about the BPTK drivers, and about CI plugin is SIOV, and the Cilium CI plugin installation is required, depends on the chosen model. For the model combination, should be follow the SIOV and the user-based vSuite configuration above, and the non-star traffic need to be used for SIOV, and east-west traffic need to be used for user space usage. Next slide, please. About the second consideration for container network and mastering is a resource configuration. So inside this one, compared with the previous RFC, we mentioned about additional parameters are required for container network. And there are different kind of resource configuration that we mentioned inside the document. The first one is the CPU isolation and NUMA activities. These corresponding parameters are the selected CPU isolation level technique and NUMA cores allocation to the port. For the port queue pace, then the parameter is the port request size. Then for the port CPU cores and memory allocation, then the parameter are the port CPU and RAM allocation. And for the sleep for the chaining, the parameter are the number of CNI ports and the selected CNI plugin. Click on the next slide. So in summary, from the adoption command, we add the 3 key environment step guidance for each container networking models in this first version after adoption. We also fix some language issues, and so after the meeting, we hope that we can receive additional review and comments to collect the document. And our goal is that after review the draft once again, after the meeting and in the next meeting, we can present again, and we hope that we can ready for the last call. Thank you.
Thank you for the presentation, and thank you for addressing all the comments during the adoption call. So any comments?
This is Luis from Telefonica. I have a comment. It would be convenient to have any recommendation about some benchmarking according to the size of the packets in this environment. So to understand what could be precisely the performance of the different solutions according to the different kind of patterns that we could find in the system. So are you considering to include something about this respect or some indications on this?
Can you speak slower? I cannot get
sorry for that. Yeah. What I was commenting is that the size of the packet of the IP packet could have some influence on the performance. Are you considering to include some guidelines or some recommendations about the kind of benchmarking according to the size of the packet?
The size of the packet?
The size,
the
number of bytes.
The size of the packet, I believe that have been addressed in previous NFV benchmarking IFC. So I don't think this is a new one for the container infrastructure. So in this only consider the additional compared with the previous, and the previous one can already be used for the container benchmarking as well.
Okay, thank you.
Any other comments on this draft? Okay, thank you, Trangong. Let's continue the discussion on the list. Okay, I don't see Vladimir. I see Vladimir connected now. Vladimir, can you hear me? No, we cannot hear you. We can see you, but we cannot hear you. Mm. Vladimir, we cannot hear you. Could you please try to disconnect and reconnect and try to authorize all the, let's say, Mythico option and for the audio? So, because we cannot hear you. Maybe if you want to communicate in some way, you can also use the chat to send a message because we cannot hear you. Yeah, Vladimir, I will move to the next presentation. So please fix your issue. Probably you can try to disconnect. I don't know if you can hear me, but okay. Maybe you can try to disconnect and okay. You can try to disconnect and then reconnect. And when reconnecting, please check that you enable all the audio option for Mythico.
And that your microphone works.
And yeah, I also check your microphone is working. Yeah.
Hello.
Yeah, now we can hear you.
Perfect.
Okay.
Oh, sorry for the.
No problem. No problem. It happens. Go ahead.
Yeah. Okay. So I want to present the progress from the hackathon and the latest status of the young model for management of network tester. So next slide, please. Is it I that control that? Or I should just say a next slide?
Yeah, you can say next slide. Yeah, say
Okay.
next slide.
So this is the quick introduction to the work so far, and we are working on a model for a network tester management in YANK, and there are alternatives that exist. Some people are still using command line, similar to Skippy, and there is the Cisco T-Rex, which is a popular network tester solution. And this year, Keysight announced the Open Traffic API, which is a new set of previously proprietary models that have been released. They do not have a YANK model for configuration, but they added a young model for status, which is quite similar to what we have. And there are other solutions for configuring a network tester. None is based on Young so far, and mostly it's the Keysight model that has a status model only, but it is very limited and only for monitoring, so you cannot configure the traffic by using that. So I spent some time looking at what Keysight contributed by releasing that, and similar to the Cisco, there is a complex models that are targeting stateful traffic generation, and there are very many details pertaining to the underlying interfaces and communication technology. Like the Young model that we are developing is very simple, and it's only based on stateless traffic generation and analysis, and it has a single stream of test frames that is supported. And this is very advantageous from the point of view of standardization, because it's keeping the work simple and focused, and it avoids like the complexity of these other models that potentially could be difficult to standardize. So I can go to the next slide. This is the set of projects that are involved in bringing a reference design. The most important work is the model itself, which has reached its 4th version. In the 4th version, there was a minor change which removed the Ethernet specific fields for specifying a test frame filter, and replaced it with a general bit-wise mask comparison of the incoming frames. So it's more general and simpler from terms of specifying to not go into detail about the fields that you're filtering, or using a more complicated filter technology, but just specifying a bitwise comparison. So that's the change. I can show it later on in the model. And there is a reference application which is in Python, which is running on RFC 2544. I have not seen a reference application for the other technologies that is a single script, and it's not proprietary. So if there is something to compare with the other available models, it would be nice to share. I'm interested in that work, if it exists. So on the device side, there is a reference design too. This is server-side software. There is a firmware in Verilog, which can be synthesized. And there is a simple hardware involving an FPGA and a 6 SFP interface platform. So that's open source. We have sent a registration for with the Open Source Hardware Association for that. It's like a shield, a baseboard in a way. So now we also have, and I think it's very important, it's a pre-silicon gate level simulation with CocoTB, iVerilog, and it is a good alternative to hardware. So now on this hackathon, we presented a solution that you can actually simulate a traffic generator and a traffic analyzer, and you can present a netconf interface to those while simulating them. And this, I think, is a very interesting thing I want to present. Just a question, can you hear me? Because I don't hear myself that well.
Yeah, we can hear you very well.
Okay, it's a bit strange. I cannot really adjust the tone. I don't know what's going through. But you can go to the next slide. Okay, so this is just a slide of the hardware platform, which we previously had as the only reference design. And if you go to the next two slides, they're just evolution of that. So this is adding a timing module, which is important because you can have a device under test that does not allow a loopback connection. So if you want to just measure one direction, then you need a precise timing. So we assume that the timing will be precise, and we have not put anything in the modules that has to do with configuring the timing. But we have this card which is providing GPS synchronized oscillator and real-time clock. So assumingly the models are applicable to situation where the receiver and the sender, the generator and the analyzer are disconnected, not the same device. Next slide, that's just going through the design. And next slide, this is like the closed box. So the most important thing I want to present is the current state of the Young tree diagram of the models. So the following slide contains the complete Young tree diagram of the IETF traffic generator and IETF traffic analyzer modules. If you can go to the next slide, please. So we are in a state where we have two models which have a tree diagram that can fit into one slide, which is very nice in terms of discussing the model. So if you are familiar or not, you can look at this tree diagram carefully and see what we have changed here. If you look into the traffic analyzer side on the left, the test frame filter container contains a mask and a data, and those are hexadecimal representation of the packets, which can provide you with a flexible way to configure a very detailed type of filter, but in the same way very simple and not involving any protocol specific discussions and complexity in terms of agreeing on something. I removed the previous one, which had like a partial implementation, just a few fields, and this one is in a way much simpler to think of. So I think it was a good change in 0.4. I think the model is simple but complete at this time. I don't think there are any conflicts, and I think there will be open questions as more people get to read that, but it is a very good base for serious discussion, and a lot of people can, if haven't done so yet, if they're interested in this work, they can start now. So yeah, on the traffic generator side, there is a single stream case, which involves a test frame type, which can be both static and dynamic and can be extended by third parties. And in the static and dynamic implementations that are recommended in the draft, there is a few parameters, like you can specify a frame size, you can specify frame data, and interframe gap and interburst gap, frames per burst. And you have a modifier section which you can specify certain octet portions of the frame can be incremented, decremented, or be random, or can be provided an action by the third party. So in terms of this this can provide you with a very flexible solution in specifying the stream that you need to test. And with the multi-stream, you can have a number of such multi-streams following after each other. And it's not more complex than that. We don't have any rules-based algorithm envisioned into that draft that can allow you to switch between the streams and stuff like that. But I think this is more than enough for a big number of the tests that currently are being carried out with non-standardized solutions. So I think this is a very valuable contribution to the benchmarking tools. Next slide, please. Yeah, this is how a design on a typical system implementing the modules would look like. It is not mandatory that you have a high-level software on top of that with the DMA and kernel. As we have proved in the simulation implementation, you can just have the cores implementing the traffic generator and analyzer. So that's probably more complex and than what could be the minimal implementation. But there is links to all the repositories and how the implementation is done. And this implementation has been progressing until now. So next slide, please. Some management transaction examples follow. I don't know how much people are familiar with Young, so I decided to just display what these models mean, so that even members that are not into Young and this kind of domain-specific issues get a bit of overview. So the next 3 slides, we'll be having a configuration of a 64 packet stream, which is this one. And you can see the datagram, which is based on the model and the Young tree that we just saw. And this simple case, it is specifying a 64 octet stream with a minimal interframe gap and a dynamic test type, which in the model there's a specification of I think a working solution for a dynamic test frame, which allows to get latency on each test frame and keep sequence. So if you're using a static type, then it would not change anything in that frame data to specify. And if you use dynamic, it changes some of the last octets of the frame when progressing with the stream. So if you go to the next slide, this is you can also look into the command line representation of that datagram. So a lot of people are used to programming tests using string-based, command line-based interfaces. And the good thing with the Young model is that you can convert automatically from the model and serialize the command line, which is deterministic and you don't need to develop. So this is what we are using actually when we're writing test cases. So in this case, this is the new solution for specifying filter on the test frames. And you can see that we specify a type of filter, which is the only supported in the draft, that can be further extended with identities specified by third parties. So you can see a type that is bit field match, and then data of the filter, and then a mask. So with that, you can connect multiple analyzers together to an interface, to a common interface in your solution, and you can get multiple streams. So this is like the approach has been to not make a complex model, but make a model that can scale in a way that you can multiply the analyzers connected. You can have different filters, and then it can track different streams simultaneously, but without putting that in the data model. I think it was still considering this a good idea. So if you go to the next slide, this is like reading the status of the analyzer while the test is ongoing. You can see the command line is just getting a path, X path in the model, and then you send a get PDU, netconf XML PDU on the protocol level, and you get the RPC reply, which contains data according to the model. So next slide, please. Yes, during the hackathon, we wanted to implement the 04 updates, make the change to bitwise mask filter for test frames. And we wanted to also demonstrate this pre-silicon test environment based on the model and test the implementation that we were making. So this is the two things we focused, and we achieved the last one, which is the largest and most exciting new feature, and we did the previous one. So this is how the system, yeah, I'm done here. This is how the block diagram of a netconf YANC system works. Like you have a netconf client, which in our case is a YANC command line or RFC benchmark in Python. It connects to a netconf server and it uses edit config, configuration change RPCs, which end with a commit. Then a transaction is committed, and the netconf server is reading and writing the hardware. Mostly writing, ideally only writing if like you have a implementation that's simple. So when you do edit config, our netconf server implementation starts doing register writes to hardware, FPGA or ASIC. So in this hackathon, we replaced the hardware with a simulation based on a CocoTBI Verilog. And to do that, you also need two additional commands. Under the block, you can see simulation run command, which progresses the simulation, and simulation finish. So in theory, you are configuring the traffic generation with netconf according to the YANC model. The netconf server receives the configuration committed and starts writing to the registers. And then you have to wait, like in RFC 2544 benchmark or any other, you do a configuration, then you have to wait a certain period. In the simulation world, you just have to progress the simulation with as much as you are expected to wait. And then you are expected to get the result. So then you initiate back to the first module, you start get RPC, which triggers a set of register reads, and you're reading register information and represent it back to the YANC netconf client application. So if you didn't know how YANC netconf works, I think this is the simplest and most concentrated case of explaining how YANC netconf works for this particular application. Now, according to what I know, it's not only we that we're doing this kind of pre-silicon simulation. It is also other alternatives, like for hardware development people, UVM, UVVM. But they're not synthesizable. They're not something that you can use from higher level protocols in the way we do. This year, Cadence and Spirent released a proprietary solution. They haven't released any details. I know some information, but I cannot comment on it. But it is a solution that works in a similar way, but it's not based on a YANC model. It's based on a REST interface that they have to their testers. So in theory, you can collaborate with the the people writing the tests with off-the-shelf Spirent testers, and you can use output from those, or you can use them while you are simulating. So pretty much the same concept, with the advantage that you have all the Spirent traffic generators supported. So in our case, we only have one reference design. In the Spirent case, you have many. Our advantage is that we are aiming for a standardization of this kind of model, and we have a Young model and not like other technology that specifies the model, which I think is an advantage, probably the only advantage. And next slide, please. So the results is that we managed to run a RFC 2544 benchmark against the netconf server, implementing the model by controlling a gate level simulation of the synthesizable traffic generator and the traffic analyzer cores in CocoDB. You have a simulation time for that in nanoseconds. So what is interesting is that we started with a complete and standard RFC 2544 benchmark. And if you're wondering how much it takes for a 10 kilobyte Ethernet device, that's how many nanoseconds it takes if you don't lose any time except configuring the registers, waiting, reading status, and so on. So it takes 1.5 milliseconds to perform a standard RFC benchmark for a device. But notice that, please. Notice that we used bogus 10 kilobyte Ethernet speed to actually simulate the data plane in real time. Because simulation takes time, but you can achieve on a laptop more than 10 kilobyte of simulation time. So if you say that your 1 gigabit device is actually a 10 kilobit device, you get a much reasonable number of frames per second that you can actually simulate. So that's what we did. We simulated 10 kilobyte Ethernet device that we could process in real time. And we published the results in a branch. There is a link. If you click on that, you can look at all the details that we published, the scripts, and you can reproduce it yourself. So you can, without the need of any hardware, run that test, bring up all the components, and get the results. So you will get the same results with this state of the project in that branch. So the results include a waveform trace, which is something that hardware designers are interested in, and a report with the verbose netconf transactions, which test developers are interested in. Now, the cool thing is that the same test, without any change, we run on a real hardware, just changing the IP address of the netconf server. And I think it's quite nice to know that before you have produced something, you can run a RFC 2544 test on it, and it will not fail when you click the button and you produce an ASIC with that core. So short RFC 2544 report and some random screenshots complete this presentation. So the next 3 slides will be some screenshots of me running the test. We didn't have time to make any more formalities because this work was done on the hackathon. So I didn't manage to present a more like a formal presentation of the results. But you can see what you get. Even if you look nearly into one of the next or the previous slides, the one with the detail. Yeah, if you go back, yeah. Now, this is how the hardware works when you configure the traffic generation with the model. So this is what you get after you're done with this netconf session and test. And you see your RFC report, you can go and see actually how the packets were being sent on the gate level. So this is the most detailed kind of simulation. This is not discrete event simulation of the network. This is gate level simulation. And you can go in and see the interface that sends the Ethernet packets. This is the GMI interface. This is an 8-bit interface. It works for the 1 gigabit Ethernet technology. So you can see that here is a configuration taking place. Configuration registers are being written to the AXI bus, which is a bus with the registers. And immediately after the completion of the transaction, traffic generation happens. You can see the packets, and if you look in a closer look, if maybe next slide, you can actually see the bytes. Here you can see the 55, which is the preamble. Then you have the D5, which is, this is the last byte of the preamble. And then you can see the first byte, the first octet of the frame, which is the destination MAC, and so on. So I'm not going to go into the details of the implementation, but knowing that you can do that, you can write a firmware or any kind of test using netconf interface, and then you can run it on a silicon level. This is something new. This is not at this level. People have been using that, but I think, at least with my experience, this is something new and really nice way to prove that this solution is good. So part of the work in standardizing this kind of modules is knowing exactly the footprint of the complexity that would require to implement them. And I think a simple module, it's better if you are considering higher speeds. This one is a very simple one. And this can be proved by looking at this reference design. And I think it's important to consider that when people standardize models that will be controlling line speed, traffic generation analysis. So this is our reference to looking into like the complexity of that. Yeah, I think I'm done.
Yeah, thank you, Vladimir. Any comments? Go ahead, Vratko.
Okay, when talking about Yank, I would like to mention that there is a lot of tooling around it, and I have posted a comment with 2 RFCs. One of them allows you to do the communication not using netconf protocol, but using REST, I mean HTTP, get and post. And the other RFC allows you to format your data in JSON instead of XML. And I think both of them are like nice to users who are familiar with HTTP and not with netconf. And maybe if you add to your servers support for this, people can use it more easily. Basically, your examples with CLI full of XML was for me harder to read. That's all.
Yeah, there are different servers, and the good thing is that they can all implement the module, so it's not limited to the implementation that we have. Like Cisco obviously has a very good solution, and there are some other companies that also have good solutions. But if we concentrate on the module, then everyone can have their own implementation. So I agree that people are used to different protocols, but if they're all based on the same Young model, then I think this solves that problem.
Yes, I agree.
And when you say it's difficult to read, I just provide that as example of one encoding. And if you're not used to that, you can probably convert to another encoding. There are tools that you can just take these datagrams PDU and just take it and convert it to another representation based on the model, JSON, and so on.
Okay.
Yeah, thank you for the question.
Yeah, thank you, Bratko. I also have just a clarification question. So, looking at your Young model, of course, I noticed that there are not so many details. So, in terms of, for example, protocols and so on. In this case, do you mean just to your approach is to make a model only for the base, let's say, parameters, and then for example, if you want to generate other protocols, so future augmentation of the models can be done. Is it correct?
The elegant part is that we are providing the freedom to the user to specify the frame representation. So if you have a solution that can take your proprietary model and things that you're using and generate a frame can be generated currently with different solutions, but you always end up with hexadecimal representation of the fields of a frame. So we think that it is a good idea to not put that into that draft. Allow people to specify the fields in a way they find best themselves, and just provide a means to put that data specification to the device. I think this is not going to change in future. I mean, this you can add other modules which can do the translation work, but it will allow you to, independently of what kind of translation mechanism you have to specify the frame and the fields, you end up with the data in a hexadecimal representation or a binary representation. This is up for discussion. Currently, it's like that. So I think this is, you understand correctly, but we don't have any limitation. You can perform almost any test that is stateless network traffic generation with that solution. There is no limitation currently, so we don't need to think that it has to be extended. I think it is just
you can specify the frame and then it can be generated. Yeah. Otherwise, if someone can find a specific use case where it can be augmented, it can be done. But in any case, the good of the Young model is that it can be extended. But I understand now. Now I understand. Thank you.
Okay.
Okay, so if there are no other comments, yeah, we can go with the next slide, the next presentation. Gabor?
Here I am. Can you hear me?
Yes. Go ahead.
Thank you. So our draft is a recommendation for using multiple IP addresses in benchmarking tests. Could you go to the next slide, please? So just a brief outline. I just prepared a few slides as reminders about the program description, why we need testing with multiple IP addresses, and the recommended solution, the usage of multiple pseudo-random IP addresses. And I would like to talk mainly about the results of measurements. I describe the measurements and then present the results. Next slide, please. So quick reminder about the program description. So as you all know, we have RFC 2544, and it has defined a lot of things regarding benchmarking, including the test frame format. And in the appendix, the test frame format has fixed IP addresses and fixed port numbers. And later on, RFC 4814 introduced pseudo-random port numbers, but it caps the usage of a single source and IP address pair when a single destination network is used. However, as technology improved and we have receive side scaling, it supports the receiving of multi-million packets per second by distributing the load of the interrupts among the CPU cores. And RSS has two kinds of implementation. The first type uses source IP address, destination IP address, source port number, destination port number in the hash function. And the second type uses only the IP addresses, source IP and destination IP address, and doesn't use the port numbers. Next slide, please. Yeah, and the problem is the unfairness. So if you would like to do some testing and your tester is able to use RST4814 pseudorandom port numbers, and if it is used to test a device under test, which uses the first type of RSS implementation, then everything works perfectly. The pseudorandom port numbers ensure the entropy for the hash function, and all CPU cores get a load, and the load is distributed evenly among the CPU cores. However, if you have this RST4814 pseudorandom port numbers tester, and you use the second type of RSS implementation, there will be a problem, because it will use the single IP address pair, and even if multiple port numbers are used, they're not taken into consideration by the second type of RSS implementation. And as RFC 2544 requires testing with bidirectional traffic, for each direction, you will use only a single core. So if you use just unidirectional traffic, then only one core will be used. If you use bidirectional traffic, then 2 CPU cores will be used and others will not be used. And you will get very poor results. However, in a real-life application, when you use this device under test as a functional router or something like that, then in the internet traffic, you have a lot of different source and destination IP addresses, so it will work perfectly if you use it for forwarding internet traffic. However, the test will not reflect its real performance. So this is why I believe that conditions for the laboratory test should be improved. Next slide, please. Yes, and our recommendation is very simple. In the same way as RFC 4814 recommends using pseudorandom port numbers, we recommend using pseudorandom IP addresses. And the questions to answer is that what ranges can be used. Of course, we have some IP address ranges in version 4 and version 6 reserved for benchmarking, so we can use these ranges. And the even harder question is what kind of ranges should be used. So if you use only a few IP addresses, maybe it's not enough to distribute the traffic. If you use too many IP addresses, then you will have a problem that the ARP, address resolution protocol, or in version 4, or NDP, network discovery protocol in IPv6 tables will grow too large, and it will just decrease the performance. So you should be careful. Next slide, please. Yes, this is the measurement environment. So it's a very simple test system. I used 2 Dell PowerEdge R730 servers. One of them was the tester, other was the device under test. And on the device under test, I use OpenBSD. I choose it because it has the second type of RSS implementation. It means that it uses only the IP addresses and doesn't use the port numbers in the hash function. Next slide, please. So this is the IP version 4 packet forwarding configuration. I used 1,000 different IP addresses on both sides. So on the left side and the right side, these ranges were used. But of course, this is the addresses used by the tester. The device and the test always use the single IP address. Next slide, please. This is the version 6 configuration. It was very similar. These are version 6 addresses. However, the numbers of different IP addresses are the same. So on the left side, 1,000 different IP addresses. On the right side, 1,000 different IP addresses. And the device and the test, again, had only single address on each side. Next slide, please. And here are the results. So you can see 2 test cases when I used fixed IP addresses and when I used pseudorandom IP addresses for IP version 4 packet forwarding tests. And I just repeated the test 10 times, calculated the median, minimum, maximum, and also the dispersion, which is calculated like maximum minus minimum per median expressed in percentage. And as you can see, there's a great difference in the results. So in the case when I use fixed IP addresses, the results were less than 400,000 frames per second. However, when I used pseudorandom IP addresses, then the results were more than 1.2 million frames per second. Always we should understand there's frame per direction. So as bidirectional traffic I used, so the number of actual frames were double as shown in the table. So you can see two difference. In the second case, more than threefold increase we can observe, and also the results were more smooth, more stable. Next slide, please. The same tendencies you can observe if you use IP version 6 traffic. The differences are lower, but the tendencies are the same. So using pseudorandom IP addresses, I could achieve higher results, and the results were also more stable. So this is what I wanted to say. Next slide, please. So I have a few questions. If you believe this solution is appropriate, or you believe that we should add something or change something, we welcome all your comments and suggestions. And thank you for listening.
Thank you, Gabor, for the presentation. Any comments? Any feedback for Gabor? Okay. Go ahead, Vratko.
Just as a curiosity, recently I encountered a third type of RSS, and it is related to IP6 packets. There is a field called flow label, and yeah, maybe in the future we will need another document if there is a test that relies on RSS working purely on flow label, even if IP addresses are constant.
Yes, it may be interesting. I have never met with a real life application which uses flow label, but if you know about, I would be happy if you could maybe write an email to me or on the list. I would be interested in that, and yeah, thank you for this idea.
Well, currently it is not important from the point of view of tester. I have only seen that as a traffic between two DUTs when using some encapsulation.
Okay, thank you.
Any other comments? Yeah, if not, thank you, Gabor. We will continue the discussion on the list, and I will move to the next presenter. Luis, right? Yeah, finally, the first in-person presenter. After 1 hour and a half of on-site presentation, of on remote presentation. Please go ahead.
Thank you. Hello, everyone. This is Luis from Telefonica. I will present the document on the benchmarking methodology for segment routing on behalf of my co-authors, Bruno, Giuseppe, Edward, and Paolo. Next, please. So the motivation for this draft was basically the fact that there was not a standard way of benchmarking segment routing solutions. So the idea was to extend the previous RFCs on benchmarking to the topic of the segment routing, knowing that we have or that there is better possible two implementations of segment routing, two realizations in terms of data plane. One, which is, the implementation is on top of MPLS or leveraging on MPLS, where basically the segment is encoded as an MPLS label, and the segment routing policy is instantiated using a stack of labels. And the other one is done leveraging on IPv6, where essentially the segment routing, the segment is encoded as an IPv6 address, and the policy is instantiated as a number of segment routing version 6 SIDs. So using a specific header. So in the way that the active segment is indicated by means of the destination address of the packet. Next, please. So regarding the history of the draft, originally the draft, originally the approach was to have two separated drafts, one for segment routing MPLS, the other one for segment routing version 6. This was the way of starting the work on this area. Both drafts were presented as version 01 in IETF 113. Along the time, we have been updating and improving the drafts. So up to the point that in IETF 118, we did reach version 08, incorporating the text from the RFCs that I referred before, so in such a way that somehow the documents become self-contained. During the presentation in Prague, also there were, even before in 117, there were comments and suggestions of merging both documents. So we received these kind of suggestions in 117, 118. And finally, we as authors, we decided to merge the drafts. That is the drafts, the both drafts. That is what I will present basically essentially today, the result of such a merging. So we in this journey we have received a number of comments from different working group participants, and also well there was the fact of having a kind of poll of interest in 117, so raising the interest of the document in the working group. Next, please. So what you can see here in this kind of heat map is the result of the merging. We took pieces of the two separated documents, integrating them in just one single document. As a result of that, some content was directly taken. Some other content has been integrated because there was some, let's say, kind of, I would not call it overlap, but commonalities, let's say, between both documents. And also in this same process, some of the sections were even extended with further content that I will comment right now. So next, please. So the latest changes, apart from the integration itself, we also included some additional content, like the proposition of also analyzing the depth of the SIDs, so in such a way that we can benchmark as well in the devices what is the implementation in terms of how many of SIDs can be supported. We initially stayed to the test with 2 of them, but with the idea of incrementally testing one by one up to the point of understanding what is the total capability of the device for supporting that. We also added in an explicit way that for the SRM routing version 6 forwarding, the IPv6 flow level must be also set. So for supporting equal cost multipath, which is stated in RFC 8754. So the integration process as well, because these commonalities between the original 2 documents, there was also some polishing of the introduction. So in order to avoid duplication between the introduction itself and the section 2, which is about semi-routing and PLS forwarding, and section 3, which is about SRv6 forwarding. And the final editorial review that was basically performed by Paolo Edward with very hard work on polishing everything. Next, please. So as next steps, considering the long story of the draft and the interest raised in previous IETF meetings, so the authors, we think that the draft is stable now after this merging, and we would like to go through adoption process. The 2 previous drafts receive a considerable amount of comments themselves, so now the result is everything integrated on just this unique or common, let's say, document. Some of us, like Boris and myself, we have shared that we already have the test following this benchmarking methodology. I can also confirm that there is some plans ongoing for coming months in Telefonica Lab for continue doing so. So now we will take this merge document as reference basis for this. And yeah, basically we consider that the adoption of the working group, the adoption of the document by the working group would also facilitate and foster the following this kind of methodology between different operators. We also discussed internally, and we suggested that once adopted also to present in a Spring working group, so to socialize the effort in, let's say, in the working groups working around segment routing. And also an option could be the Summer Autumn version 6 operations working group, it finally is formed. So, but anyway, clearly to the Spring working group to take this and socialize with them and also receive feedback from that front. And that's all from my side. Thank you.
Thank you, Luis. Any feedback, any comments? Okay, yeah, okay, I see Gabor. Yeah. Go ahead, Gabor.
So I myself was okay with two separate drafts, but I also okay that the two drafts were merged. But I think we have reviewed it several times, so I think nothing should prevent us from adopting it. So I recommend the chairs to initiate an adoption call after this meeting is over, on the mailing list, I mean.
Thank you, Gabor. Any other comments? Okay, yeah, regarding the adoption, I will discuss with Sarah, and yeah, probably we can have some follow-up after this meeting.
Thank you.
Let's go ahead. Carlos is not connected, so I think Chin. Yeah, it's not connected. Go ahead.
Okay, thanks for chair. And so Carlos is not here, so I, on behalf of the author, present this draft and the topic about characterization and benchmarking methodology for power in the network device. And next. So so the background actually, the environmental impact, on the network infrastructure, is not trivial. So ensure the energy efficiency become more and more important for the operator to operate their network. So the benchmarking methodology defined here can help two parties. The first is the operator, so they can get the energy efficiency visibility, so they can can develop energy efficiency strategy. For vendor, actually, they can test the energy efficiency for their own device and to meet operators' requirements. So for this benchmark work, actually, we target two objectives. The first is assessing which system perform better over a set of well-defined scenario. So this is more focused in the current stage. The second is measure the contribution of subsystem to the overall system performance. And actually, for this object, we haven't touched in this chart, but we will touch this in the second phase. The current stage, we aim to compare the energy efficiency for individual device. Next. So the terminologies in this draft, actually, we actually have three key terminologies defined in this draft. The first is total weighted capacity of the interface, and second is total weighted power, and the third is the energy efficiency ratio. So you can see this terminology actually as three metrics. You can see the first two metrics actually can be used to derive the third metric, energy efficiency. So each metric have their own mathematical formula. So this actually based on ETSI standard, actually yeah, uses similar terminology. Next. So for energy consumption, how you measure this, how do you benchmarking for each individual device? Actually, if you actually under the normal workload, for example, you have workload 20% or 30% or 50%, you choose to measure the maximum power drawn by the device. So in most cases actually doesn't accurate reflect the real actual power to be used. So we need to define some test procedure, test method. So to formulate a consistent benchmarking method. So in this benchmark method, we need to consider various different workload variations. So typically they will choose 0%, 30%, and 100% in many, if we reference, ETSI standards. And also we consider different test conditions. So one example, since it is a lab environment, so we may set a temperature, to specific temperature value range. Maybe we can set, some other like humidity and or atmosphere pressure. These kind of test conditions. So based on these, test conditions you set, actually you can make the measurement result can be repeatable. Each person or each tester can get the same results. So the new metric we use here is energy efficiency ratio. So you can see, so they can calculate based on two metrics. So this is really we can use total weighted capacity of the interface divided by the total weighted and power. So in this formula, actually we consider there are some factor. For example, the weight actually weight value or traffic load level, the weight value, and so you can see the example in this table actually give how to choose this weight value, or we call the weight multiplier, or and also the traffic load level. Usually they depend on the network device type or locational device. So in these cases, we usually consider, for example, their location is in the core network or in the access network, or the equipment could be the switch or could be the router. Yeah. Next. So test methodology, we actually need to set up, test the environment for this. So you can see this simple test environment setup. Actually, usually we require this device on the test, connect to the both tester and also power meter. For power meter, only measure internal energy consumption of the device. But for device on the test, they also dissipate actually significant amount of the heat actually. But for this external heat, we didn't count actually in this test setup. Next. So how to make benchmarking results repeatable? Actually, we need to characterize the traffic and the devices. So the idea is to portrait the traffic or portrait the device. For traffic, actually we consider traffic load, and we think the traffic load will affect energy consumption most actually. And also to investigate this traffic load, we found the traffic type and packet size mixture and percentage overall traffic will also affect traffic load. So so based on this, so we know actually, so this fine granularity, these kind of factors will affect the end of the energy consumption. So this is the traffic characterization we currently consider, but we do receive some comments. Yeah, we need to consider more factors. For device characterization, actually currently we consider like interface type, for example, whether it is optical interface or packet interface, and also if it is optical device, actually you need to consider the type of the connector or transceiver. So for example, it could be the fiber optical transceiver module. So these really portray the device you really test in this kind of lab environment, so make results more accurately or repeatable. And in addition, we also consider the 9-card capability. For example, whether the 9-card how many ports actually can be supported in a 9 card, or the aggregated bandwidth for each 9 card. So this kind of constraint that we consider for the device. And yeah, next. So the benchmarking test, we actually focus on several metric tests, for example throughput and the power. Actually, the power we actually can break it down into base power and also power draw by the device within the traffic load. And the traffic load level we set actually currently usually we choose 0%, 30%, and 100%. So in this way, actually we can to calculate the energy efficiency ratio. And in addition, in this chart, we also define the reporting format. Actually, I don't want to give a detail to discuss what the format look like. You can take a look at the draft. Yeah. Next.
Can you go a little bit faster so we
Okay.
can give the opportunity to the last
Okay,
presenter?
just the last slide actually. This is a summary for discussion. We already present this, it's 0.0 version draft in the environment impact IP intermeeting before this IETF 119. So we got a lot of input from many contributors, for example, Tolis and Marisol, Alex, and Shrish. And so the comments we listed here, actually, we already consider, and we will, track this issue, how this can be addressed. And for many in this discussion, we did receive, Louis' comments actually, and we actually the idea is we need to, extend our the scenario to more, more realistic scenario to cover more useful use cases. So so to save time, actually, I stop here. Yeah, thank you for listening.
Thank you, Jim. Yeah, all these comments, I think that if there is some discussion on the impact main list, we also need to cross-post on the benchmarking. So also benchmarking working group people is aware of that.
Yeah.
Okay.
We actually, we already set up the GitHub. We will track all the open issue. Yeah.
Okay.
Yeah.
Good. Yeah, I think no time for comments. Let's bring to the list and please. Yeah, you have 6 minutes.
Yeah, I will try to be quick. Hi, this is Xu Song. I will introduce a new document called SRC Service Benchmarking Guideline. Next slide, please. Here is some background. Actually, as Luis has already presented, there is a stable SR6 benchmarking, segment routing benchmarking work in working group, and the basic idea of this document is trying to give the benchmarking methodology for SR6 and SRMPS forwarding plan behavior, especially define the expected throughput of different roles in a segment routing network, including source node, transit node, and other kinds of nodes. Next slide, please. And also there is some previous working group document which has been expired, but we find it is useful because it has defined EVPN capability benchmarking. And the topology used in the document is showed here. It is composed of multiple nodes to provide EVPN service. And for our document, EVPN service is an important type of VPN solution, and it is one of the VPN service we want to transport it through a services network. Next slide, please. Yeah, so for our proposal, the motivation is that we want to introduce in the SRC service benchmarking, especially based on the existing working group work. So we're trying to propose that we should benchmarking the capability of a SRC6 network, which could convey different types of services. Including SRC's best effort services, SRC's traffic engineering services. And in the TE part, the SRC's policy with compression and without compression should be considered. And different types of services include internet services, layer 3 service, and also Ethernet, EVPN-based layer 2, layer 3, and the VPWS service could be considered. Next slide, please. Here is some example of our proposal. Take SR6 best effort service as an example. There is an objective to benchmarking the capability, and the procedure is basically try to deploy different service and convey different services through SR6 best effort the SR6 network based on SR6 best effort path. And the expected results is then the different service could be transported properly, and also there is no packet loss. Next slide, please. Yeah, also other SR6 service related features may be considered. Also, for example, in our document, we have included SR6 OEM, SR6 reliability, and also service performance. Next slide, please. Yeah, actually, we think this work is basically based on our real test case in our test lab, especially the with some collaborations with service provider. So we think it is a useful guideline for the working group, especially to provide benchmarking for SR6 service. And also, as you may find that we call this document guidance, guideline or guidance, because there is no no topology and no quantitative result that it has been, that is all these kind of aspects haven't been included in the document yet. So we think it requests further contribution from other interested group or organizations. We would like to seek comments from the working group whether it is a good direction to discuss. Yeah.
Thanks. Yeah, we have still 2 minutes. Let's see if there are some comments.
Yeah.
Otherwise, okay. Go.
Thanks. So two quick questions on this. The draft is intended because I couldn't read yet. So it's intended for interoperability, or would be a single vendor scenario? What we are trying to benchmark?
It's only one vendor. It's not interoperations. It's just the capability benchmarking.
Okay.
Yeah.
And are you considering, in order to facilitate the reproducibility of the benchmarking methodology across different vendors and so, some guidance as well, for instance, in terms of the IP addresses to be used, or the topology and all this kind? So that will be included in the document?
Actually, we are preparing another separate document for the exact methodology for benchmarking. This just kind of guideline to select feedback from the working group whether it is the right direction.
Okay, thank you.
Mm-hmm.
Thank you.
Thanks.
Okay. Yeah, let's continue the discussion on the list because there is no more time. No. Okay, I think we reached the end of the session. So thank you, Warren. And only your presence is okay. See you in Vancouver. And yeah, please review the documents and comments on the list. See you in Vancouver. Probably the
time difference. Yeah, you know, once before she was off by a couple of hours.
It also affects some European people that Yes, plus 10. Yep. Oh, well. Cool. See you later. Sì, no,